Hello everyone, this is Mr. Appel, and now we're going to look at a proof involving parallel lines that's a little bit more interesting, that requires a little bit of thought. And in fact, what might be confusing about this particular proof is there are many different ways that you could solve it. I'm going to show you one method and try to just talk a little bit about some of the others. If you want to try and do it yourself first and then compare it, that's fine. Or just watch and then take good notes. Okay, so I see in the figure that these two lines K and N are parallel, and that was given to me, so of course my first step is just to state that they're given. Once I've established that those two lines are parallel, which in this case I know that because it was given to me, so that was easy, I know all of those different theorems about parallel lines are true. I know all the corresponding angles are congruent. I know all the alternate interior angles are congruent. I know all the same side exterior angles are supplementary. So I know lots and lots of different things here. So the goal is to try to connect the angles that we're interested in. In this particular example, they're talking about connecting angle 1 to angle 7. So my first question is, do one of those 5 theorems apply to angle 1 and 7? Well, they're on alternating sides of the transversal, but 1 is on the interior and 7's on the exterior. So there is no direct connection. None of our 5 theorems applies here. So we need to find a way to connect angle 1 and angle 7. There are lots of different ways you could do this. You could do this in 37 steps. You could do it in just a few steps. I'm going to show you one way to do it, and you can try others, like I said. Okay. So what I notice is that angle 1 and angle 3 are corresponding angles, and so I know those two must be congruent. So I'm going to go ahead and say that angle 1 is congruent to angle 3, and the reason I'm going to give for that is that corresponding angles are congruent, but again, you have to state the theorem as an if-then. This is the shorter version. If the lines are parallel, then corresponding angles are congruent. Okay, you do have to write it as an if-then. You need to say if the lines are parallel, then whatever you're stating. Okay. So the next thing I'm going to do is I'm now going to say something about 3 and 7. So I brought angle 1 into the proof. Now I want to bring angle 7 in. And I notice that 7 and 3 are a linear pair. So I can use angle addition or the definition of a linear pair to state that the measure of angle 3 plus the measure of angle 7 is 180 degrees. And again, that's using what we said we're allowed to assume from the figure, which is that anytime a pair of adjacent angles makes a straight line, that straight line measures 180 degrees, that the angle measures 180 degrees. So we can state the angle addition postulate, or you can use definition of a linear pair. Either reason is fine. Okay. Now, I've got 3 and 7 equal to 180, and I know 1 and 3 are equal, but I want to say something about 1 and 7. So what I'd like to do then is just replace angle 3 here with angle 1. Replace, substitute, same thing. That's what that word means. So I'm going to rewrite the statement now. And hopefully you can see what I've done is I've just replaced angle 3 with angle 1. That's just a simple substitution. That's the substitution property of equality. Certainly fine to abbreviate that as POE, property of equality. That's good practice rather than just writing substitution. You really should do that. That's our attention to detail and precision that's so important. Okay, well now I'm almost there. I've said that 1 plus 7 is 180. Well, what's the definition of supplementary angles? Definition of supplementary angles is a pair of angles whose measures add up to 180. Well, I have just established, I've just proven that those two angles add up to 180. So I can now say that angle 1 is supplementary to angle 7, and my reason being the definition of supplementary angles. And that is your proof. Again, lots of other ways you could have done this. Just briefly, I'll just talk through. You might have instead said that you could have actually saved a step here. I think it would have been shorter to say that angle 1 and let's say angle 4 are supplementary. That's same side sup. If same side interior angles, if the lines are parallel, then the same side interior angles are supplementary. So you could have stated that 1 and 4 are supplementary. You then could have used the vertical angles theorem to say that 4 and 7 were congruent. So then you would have had 1 and 4 supplementary, 4 and 7 congruent. A substitution replacing 4 with 7 would give you 1 and 7 supplementary. And it would save you a step because you used supplementary in your first statement, and so you wouldn't have to use definition of supplementary there. Again, lots of ways to do it. Ask questions if you have any, and good luck with the rest of your proofs.